Electrochemistry. Electrochemistry is the science that deals with the study of interconversion of electrical and chemical energy. Based on the ability to pass through the electrical current, all substances are classified into conductors, insulators, and semiconductors. Those substances which allow electrical current to pass through them completely are known as conductors. Examples are metals, alloys, and fused electrovalent compounds. Those substances which do not allow electrical current to pass through them are known as insulators. Examples of insulators are wood, silk, cotton, glass, rubber, organic compounds like benzene and carbon tetrachloride. Those substances that allow the electrical current to pass through them partially or possess very low electrical conductivity are known as semiconductors. Examples of semiconductors are silicon, germanium, oxides of manganese, cobalt oxide, titanium dioxide, etc. Conductors of electricity are further classified into two types, depending on their mode of transport of electrical charges inside them. These are electronic conductors and electrolytic conductors. Metals and alloys conduct electricity due to the movement of delocalized outer shell electrons present inside them are known as electronic conductors or metallic conductors. Electrical conduction through metals does not bring about any chemical transformations. Electrovalent or ionic compounds conduct electrical current in their dissolved state or in their fused state only. These compounds consist of ions of opposite charges. In aqueous solution, they exist as ions, and if we apply electrical field, these ions migrate to respective electrodes, exhibiting electrical conductivity. This mobility of ions is responsible for conduction of electricity through electrolytes and is referred as electrolytic conduction. Passage of current through electrolytes is accompanied by chemical changes also. Now it's time to see the differences in the properties of electronic and electrolytic conductors. Pure metals and their solid solutions such as alloys are called electronic or metallic conductors, whereas electrovalent or ionic compounds conduct electricity through their ions present in fused state or in dissolved state. Free and mobile electrons of the metallic atoms or alloys are responsible for electrical conductance, and the positive holes in the metals move in the opposite direction to that of electrons. On the other hand, in electrolytic conduction, ions with positive and negative charges conduct electricity and move towards cathode and anode respectively. Here this electrolysis occurs when electrical current is passed through electrolytic solutions. There is no chemical change in the electronic conductors when electricity is passed. But in electrolytic conductors, chemical change occurs. In electronic conduction, there is only flow of electrical energy, but there is no transfer of matter. While in electrolytic conduction, there is actual transfer of matter since ions move towards respective electrodes. In electronic conduction, conductivity of metals decreases with increase in temperature. This is due to the enhanced thermal vibration of metal atoms, disrupting the movement of electrons passing through them. In electrolytic conduction, the conductivity of electrolytes increases with increase in temperature. This is due to increase with ionic mobility.
Hey there. Subscribe to my channel. And also press this bell icon.